Okay, number 23. Number 3 is a problem comparing an airplane's altitude and the altitude of a hot air balloon. I have the equation for the airplane highlighted in yellow, the equation for the balloon highlighted in green. When I do my graph, I'll do my graph in green for the balloon and orange for the airplane. I already put my axes on here and here, altitude in thousands of feet. So each one of my boxes is 500 feet, then 1,000, and then every other box then gives you up to the thousands. And then my minutes from 1 minute to 10 minutes. So I have my scale, my label. You have to play with those a little bit sometimes. So I need to graph this. So I'm going to graph the airplane first. The airplane's starting at 4,000 feet. And my slope is down 500 over 1. So each of one of my boxes is 500. So down 500 over 1, I can do a graph all the way down and create that. Let's edit my line to make it orange and solid. Now, other things you could do to make your graph is you could make a table and you could plug in different things like what is it at 0 minutes? It's at 4,000 feet. What is it after 5 minutes? 500 times 5 would be 2,500. Negative 2,500 plus 4,000 is 1,500. So after 5 minutes, it's at 1,500 feet. You could find the x-intercept by plugging in 0 for y and determining that that is 8. So what are the y-intercepts and what do they represent? The y-intercept for the airplane is 4,000, and that represents its current altitude, or its altitude when it starts descending. So altitude before descending. The x-intercept is going to be 8. That takes 8 minutes before the plane is on the ground. So 8 minutes until landing. I also want to graph the hot air balloon. The hot air balloon is at 2,500 feet to start. That would be my green graph. And I'm going down by 100 feet per minute. Since my boxes go down by 500 feet, 500 feet would take 5 minutes. So if I go down by 500 feet, that will be over at 5 minutes. Another 500 feet will be another 5 minutes. I can also make that with a table as well. I could say x and y. I could say at 0 minutes, the hot air balloon is at 2,500 feet. Where am I at 5 minutes? And then use this equation. Negative 100 times 5 is negative 500. Negative 500 plus 2,000 is 1,500. But I didn't graph that in the right spot on my graph. So let me double check something. 5 minutes. It's 500 feet. I should be at 1,500 feet. Oh, it's plus 2,000. That's why. So I started in the wrong spot. I'm going to have to move these points down. I started in the wrong spot. So that's accurate now. And what can you tell from the slopes of the graphs? Well, I can tell that the orange line is steeper. So because the orange line is steeper, we could say that the plane is descending faster, or it's descending at a greater rate. And I think that's all I need to do for number 23.